Welcome to Unit 2. This is Lesson 1.0, Functions 101. Right, in this lesson we're going to learn about functions and how to document them. So first off, recall a function notation from math class. So this is an example. F at r equals pi r squared. So in this case, f is the name of the function, right? So this could be f or g or whatever we want. And in coding, we're going to pick this to represent something meaningful that our function signifies. R is the argument or the parameter that goes inside. This is kind of like if f was print, then r would be the thing we'd be printing, right? So this is the thing that the function works with to do something. And what's on the right side of this is this equation is an expression, which we call the function body. And this is the thing that actually does something with whatever we've put in here for r. So for example, if we calculated f at 1, well, we would have pi times 1 squared, right? So we take this r and we replace whatever this value is each time on the right side, wherever we find that r, which is just one place, right? So pi times 1 squared is really just pi times 1, or pi centimeters squared. F at 2 would be pi times 2 squared, right? Which would equal 4 pi centimeters squared. And f at 3, well, now we'd be squaring 3, right? Multiplying that by pi, so we'd get 9 pi centimeters squared. So in many ways, Python functions work the same way and have the same terminology. And we're going to work through an example, first off, that will allow us to actually evaluate properties of a cylinder. So recall the DRY principle, which means don't repeat yourself. Right? Repetition is the root of all software evil. So if your code is littered with repetitive blocks that just look all very similar and basically do the same thing, then you are repeating yourself and writing inefficient code. And functions really just give us a way to uphold this principle, not to be repetitive, because we can call a function every time we want to use it, rather than writing out that code in full in our code body. So let's start with example 1. Alright, so example 1 says, write a program that calculates the surface area and volume of a cylinder with a given radius and height. Okay, let's start by creating a new folder and note file. This is unit 1, so we can add a folder here. We'll call it unit 1. Here we go, and we'll just close this one, and let's add a file, 1.0 notes.py. There we go. So functions are useful when you have to do the same task multiple times. And one thing it looks like we're going to have to do here is find the area of a circle, right? Because we have this one to calculate, and the same one over here, right? So let's start by creating a function to do that. What we need to do first, of course, if we're going to be working with circles, is get access to pi from the math library. So let's do that. We'll type from math import pi. Okay. Next, let's make a function. So the first thing you have to do when you want to make a function is start with the keyword def, which is short for define. So you type in def. And that just means I'm going to make a function, okay, or a class or something else later, but for now, just functions. After that, type the name of the function. So we're going to call our function circle area. And right when you do this, use upper camel case, right? So make your function name descriptive so that its name means what it is. In this case, area of a circle, so circle area with capital A. And then type a set of brackets, okay, just like you do when you call any other function that we've worked with. And inside, you get to choose any parameters that you want your function to have, okay, that you're going to pass values into later when you call this function. So for us, well, if we're going to be finding the area of a circle, we basically need this to calculate it based on the radius, right? So we're going to have radius as a parameter. The last thing you need to do is put a colon at the end, because every function initiates a block into which we put our function body. And for now, let's just put the pass command in there. That will satisfy it, and we'll just go back to the main thing, the main line here. And so this function is technically empty because of this pass command, but I just want to show you something. So So what we could do now, since we've defined our function, even though it doesn't do anything, is we could call the function by referring to it like this, by typing circle area 3, right? So if we actually typed circle area 3, then what this would do is it would evaluate our function, and this wouldn't print or assign itself to a variable or anything, but what it would do is it would actually go up to here, and it would give radius the value 3 and execute all the code that's in the block of the function, and use this value of radius that we could put in our block to actually help do something. So so let's now give this function some content so this will actually do something. Well, we know that the radius of a circle is just pi r squared, right? And so we want this circle area function to evaluate to that amount. So what we can do is type return, okay, which is a keyword that says that tells the function to end and return to the place it just came from. So return, and then we're going to type the value that we want circle area to take, which in this case is going to be pi times radius, right, squared. Remember, that's 2 asterisks. Okay, so now we're in business. Now we actually have a value that the function will return. So return says go back to wherever you called this function and evaluate to this value, whatever you put on the right here of the return statement. In this case, it's going to be pi times whatever radius is passed squared, right? So if we type circle area 3, then radius will be 3, and this will return pi times 3 squared, right? And so this will evaluate to 9 pi. Okay, let's actually just print that. Let's add a print statement here. And we'll press F5, and we should see that this should output, there we go, 28.27 ... lots of decimal places. And that is the radius of a circle of size 3. And we could change this value now to whatever we want. We could make it 5, and it should be a little higher, right? 78. So this is really cool now. We have a function that we can use this to find the area of any circle by just changing this number right here. It's like a custom function that we've created. So this is really awesome. And this kind of thinking, creating functions, is going to be the backbone. It's going to be the bread and butter of creating tools for your programs going forward in this class. So let's take a minute to look at execution before we go any further here. And to do this, let's copy line 5, and we'll just paste this here, change it to 3, so that this function is called twice inside a print statement. Okay, and let's just add one line there just to space that out nicely. And let's put a breakpoint at the top, and then we're ready to step through. Okay, so pressing F5 brings up our debug pane over here, and our steps up here are stepping through options. And so we're stopped at line 1. Now remember, there's kind of like 2 main ways to step through your program. You can use step over and step into, and I basically said we'd look at step into later. Well, today we're going to look at step into, because these function differently when functions are involved, and we're going to see how this works. Okay, so first of all, let's use step over and watch what happens. So it's going to import math, import pi from math. It's going to define the function. Then it's going to print the first, print the second, and then it's done, right? I'll press stop. Now, so basically that worked the way that we're used to seeing, right? Except that it didn't seem to run this return statement in here, right? It jumped over that. Well, let's run this again. Press F5. This time, let's use step into, which is F11, right? So if we press F11, then it's going to define, all right, it's going to define pi, it's going to go here, it's going to define circle area, then it's going to jump back down here to line 6, and it's going to print circle area 6. Now step into brings us into the function that's called. Okay, so before we didn't get this, right? Step over basically just calculated this and printed it immediately, and then went to the next line. But step into, okay, takes us specifically into the flow. Now really, the flow here isn't any different. But step into shows us, okay, it actually shows us everything that's happening inside the function call. whereas step over just skips it. It runs all the lines in the function and evaluates it in one go, right? So if you use step into, okay, whenever you call a function, that means you're going to go into that function and step all the way through that function. So if we had 40 lines of code here in this function, then we would have to step through them all, right? However, if we didn't want to do that, we just wanted to see what it would evaluate to, then we could just use step over, and that would bring us to the next line and execute that function as it is. Yeah, so in other words, if we keep pressing step into, right, now it's going to come back out to line 6, and it's going to print that area, and then, of course, we're going to step back into the function, right, and calculate the area of the circle with radius 5 this time, right, and then print that when it's done. So let's remove this breakpoint for a second. I want to show you one other thing here. If we were to cut this line 6, okay, and paste it in front of the function definition, so that it's going to call circle area, okay, in a place in the code before we've defined circle area, then you'll see that we should get an error. Okay, and predict what we're going to see here. Right, so here you go, name error, circle area is not defined. So it's saying, what are you doing? You can't call print circle area 3. I have no idea what that is, right? We haven't reached it yet in the code. So the point here is that you can't call a function, you can't use a function until you've defined it. And everything runs from the top down, right? So once it's defined, then you can call it. In other words, we can't have this here. We have to put it back down here after the point in the code where that function is defined. So that's just something to watch out for. Alright, so let's go on here and create a function that will calculate the volume of this cylinder. And in order to do that, right, what we're going to have to do is define a function that has two parameters, which is a radius and a height. Because, of course, every cylinder has two dimensions that are important. We have radius and height, or diameter and height, but we'll use radius in this case. Okay, so let's delete these, and we'll define volume. And we need to this time give it more than one parameter. We're going to give it radius and height. And then start a block. And now what we want to do is return a value that would represent the volume of this cylinder. Well, we know that the volume of a cylinder is just the area of the base times the height. But we could use this circle area function that we previously defined to represent the area of a circle to calculate that, right? So we can actually include this circle area function right in the return value of another function, so long as we've already defined that function, which we have, right? Because this is below circle area. So we could say return circle area. And of course, the radius of this circle, of this base, is this radius parameter that we have passed into our volume, right? So this is going to be the radius. And then we need to multiply this by the height that we also pass as a second parameter into this function. Okay, so let's add a print statement to line 9 to test this out. So we're going to print volume. And now let's try a cylinder of radius 3 and height 5. And make sure you put commas. Put a comma in between these two parameters, right? Also note how your tooltip, right? Your tooltip comes up and actually shows you the parameters that you've already written for your function. And this is really cool because it helps you to remember, you know, how to use your own function that you've defined. Because you know this function might be pretty far away in your code somewhere. It might be like 5 screens up, right? So this is kind of handy. So we'll execute this and we'll see what we get for our volume. Okay, so it's saying that the volume is 141, right? And I just want to show you the execution here because this is pretty nifty, right? We have kind of like we're using a function inside another function. So if we press F5 and step through, and we'll use step into, right? Step into, it's F11. That's what I'm pressing now. And you can see we're going to define the first function, define the second, and now we're calling volume, right? So now we're going up to the volume body, but since the volume body calls circle area, now we're going up to circle area to calculate that, coming back to do all the math, right? And then going back to line 9 to evaluate, to print the value of volume 3, 5, which is what we eventually get in our print statement. Okay, so the next one we should do is surface area. We'll stop this. Let's go up here for a minute and look at the surface area picture again, the diagram I included. So remember that surface area is basically just the sum of all the exterior surfaces of the shape, which in this case is a circle on the top and the bottom, both the same size, plus the area of this rectangular shape, which is really just the unfolded or unwrapped lateral outside edge of the cylinder. Right? So this is always just the same height as the cylinder. And then the width, which is the circumference, the distance all the way around this edge, which is really just 2 pi r, right? So in other words, this area is 2 pi r times the height of the cylinder. Okay, so with this in mind, let's try to create a surface area function. And I would invite you to take a moment, pause the video right here, and see if you can create your own surface area function, and then check back in a moment and see how you do. Okay, so hopefully you gave that a shot. So here's how it's done. So we'll define surface area, and of course we still need a radius and a height to do this, right? And in our function body, we want to return this time basically 3 things, right? We want to return the, 2 times the circle area, the radius, right? So the 2 circles of radius, and we want to return plus this rectangular area, which is going to be 2 times pi, right? Times the radius, 2 pi r. And that's our width times the length, which is the height, right? So times height. Okay? And so this is the expression that we actually need to return for our surface area. And let's just add a print statement here. Surface area, 3, 5. And we should see that these are quite different. We'll press F5 and just see what we get. So we got our same 141. This time we got, actually, they're not that different at all. It just so happens that for these values, we got 141 cubic centimeters, but 151 square centimeters for our surface area. Okay, so at this point, you can pause the video and you can go ahead and complete Replit assignments A and B for section 1.0. And come on back here when you're done. Okay, welcome back. So we're going to finish this lesson by learning how to document our functions. Now the thing is that our program is working fine, but it's not done because there's no documentation. And documentation is a critical part of writing understandable code. Because in the real world, code is written to be read by others and only incidentally to perform tasks. Almost always when you're coding in a real world environment, somebody else has to read your code and figure out what it does, because you code part of a program and somebody else has to use your code in the bigger picture. So we all have to learn to write really readable and usable code for the purposes of collaboration and co-creation. So what we can do, one really good way to do that is to document any functions that you create. And really what we can do is we can have a comment at the start of our function called a docstring. Okay, this is a keyword, a special word that's used to describe this comment. And there's 3 parts to a docstring. This is how U of W incidentally teaches these docstrings, and we're going to use their format, at least for those functions we'll be documenting throughout the remainder of this course. So you start with a description. Now this is the general purpose of the function in one concise sentence. You can make this longer, but keep it short, okay? And if you find yourself having to do a lot of explaining, really you probably could be writing more simpler functions, right? Break down your function into simpler tasks. Then, describe the input of any parameters, or describe any parameters, their data type and restrictions that you're passing, and put 1 line per parameter. And finally, explain the output and return value. and its data type. Right? So for example, here, right, circle area, what we could do is we could add this docstring. We use triple quotes, typically, quote, 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 and then type calculates. Actually, let's put a set of end quotes. There we go, just to get rid of all the nasty red lines. And now on our first line, this is our description. So we'll say calculates the area of a circle, right? That's what this function, circle area, does. Now on the next line, we're going to have to describe radius because this parameter, right, is required in order to use our function that we've made. Of course, every circle needs a radius. So radius, we type in the parameter followed by a colon, and now we describe it. Well, this is just the circle's radius. And now we talk about the float, and so you can say as a float. So as a float and greater than 0. That's the restriction on this. In other words, our radius has to be larger than 0, it has to be positive, not negative, right? And so you can state that as your restriction. Okay, and finally, we can add a output explanation. This is the third line. And really, we know that this will return, okay, the area as a float, right? So the area, and you could even here state the units, but really the units aren't important. We could pass any units to this function. It could be meters, right? The radius could be in meters or feet. So yeah, we don't have to be specific. And this is our docstring, right? This is done. So I can now, where I can sit down and read this function as somebody else and understand what circle area does. So let's do the same thing with the volume function. Well, this one has two parameters, right? So we'll create our docstring, quote, 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 and we'll put our description here. So of course this just calculates the volume of a cylinder. And you know, I mean, our function name here doesn't say volume cylinder, it just says volume. So, right, this isn't as descriptive as it could be. So it's really important we're talking about the volume of a cylinder, right? Because what could it be? A square, you know, a cube or a rectangular prism, or who knows, right? So in any case, write a description here that makes sense. Okay, now we got radius to define. So this is, again, just the circle's radius as a float greater than 0. And then we have the heights. Right, it's our second parameter. Right? Got to have one line for each parameter. And this is, of course, the... Oh, and actually, this is the cylinder. Pardon me. This is the cylinder's radius as a float. And this is the cylinder's height. Right? Also as a float greater than 0. Okay, and this returns the volume of the cylinder. Okay, as a float greater than 0. Of course, that's going to be positive as well. Okay, and so this is how to document the volume function. And really, we're going to have a very similar comment for the surface area. The only difference, of course, is that we're going to be changing volume to surface area. So really, let's just copy and paste this and change each of these to surface area. So let's just double check this. Right? Calculates the surface area of the cylinder. Radius is the same, height is the same, and returns the surface area as a cylinder as a float greater than 0. Okay, and so really, this is how to document your functions. And for the assignment here, right, that I've given you on Replit, if there are making functions, you must document them. Okay, you must document them if you want credit for these assignments. Okay, so read the directions within these carefully and be sure that you're following them. This won't be the case for every function that you write, but for the purpose of learning to do this, you need to do this in this section. So you can now go ahead and work on Replit section 1.0 assignments C to E, and that will be the end of this lesson. Good luck with those, and we'll see you in class.